Hello all, welcome to my channel. Today we will discuss lead code question number 560, which is sub sum equals k. So let's read the question. Given an array of integer nums and an integer k, return the total number of sub-array whose sum equals to k. So you will be given an array nums and an integer k, and you need to find the total number of sub-arrays whose sum is equal to k. So a sub-array is a contiguous, non-empty sequence of elements within an array. So basically, you will be given an array and you have to return the count of sub-arrays whose sum will be equal to k. So let's see the example discuss. So it is given nums 1111 and k is 2. Means you have to find all the count of all the sub-arrays whose sum is 2. So there are two sub-arrays whose sum is 2. One is this one and another is this one. So that's why output is 2. Now it's coming to next test case. It is 1, 2, 3 and k is 3. So here you are having again two sub-arrays which are 1, 2 and this 3. So you are having two sub-arrays whose sum is 3. So let's discuss the approach. So one of the brute force approach would be that you can simply find all the sub-arrays and then find the sum of that sub-array and check if it is equal to k. If it is equal to k, then you can count that. So time complexity for this will be around n cube and a square for forming all the subarrays and another n for finding the sum of that subarray. So uh, obviously time complexity is very high. So you need to think of some optimized approach. So let's see the optimized approach, what we can do. So in optimized approach, we can use prefix sum. So how we can use that? You can, what you can do, you can take a variable sum and you can iterate it over the array and keep it adding into the sum, the elements of the array. Okay. And also you need to have a map. Okay. Unordered map you can take. And in that map, you can take sum as the key and count as the value. I will explain what is this sum and what is this count. Okay, so you can traverse this array. So first element is 1. So you will add this 1 to your sum and you will check, not you will check, you will simply uh, you will also have a count variable. In that count variable, you can add whatever count for this sum minus k you have in your map. Okay. So why you will do this? Let's see. Uh, if I will if I will create a prefix sum of this array, then what I will have? I will have 1, then I will have 2, then I will have 3. Okay. So uh, if standing at any index, uh, if I subtract k from this prefix sum, then I'm getting 0. Okay. If I'm getting 0 means we are getting a sub array whose sum is 0 because this is a prefix sum. And if I'm subtracting k, am I getting zero? And I am getting zero. Then we found a subarray whose sum is k. Okay. Now coming to this three, if I subtract k from this three, so 3 minus 2, we will get 1. Okay. So, and this one occurred previously in my prefix sum, which is this. Then also we are getting a subarray whose sum is equal to k. Why? Because uh, if uh, if I'm getting a sum prefix sum after subtracting some value from this three, so means starting from that index, not that index, from means, uh, ignoring that index from next index to that index, if I will sum, I will get my k. Because if I am subtracting some value from this three and I'm getting this, this means there is a subarray present whose sum is equal to k. Okay, so this is the main logic that we are following here. We are each time we are adding the element to our sum and uh, and uh, and checking the map. If sum minus k is present, then we are adding to our count, and at the end we are increasing the count of that sum in the map by 1. Uh, okay, so uh, let's dry run on this example. And at the beginning, what I will do, okay, in my map, I will initialize MP of 0 as 1. This we are doing because if if we are getting prefix sum as suppose equal to k and we are subtracting, then we will get 0. Okay, so we need to count that also, but 0 will not be present in the map. So we need to add a 0 with the count 1 to consider if the prefix sum is equal to k. Okay, so now I'm at this index, so I will add this to my sum. Okay, and after adding to my sum, I will add to my count sum minus k. So sum minus k is sum is 1 and k is 2. So sum is 1 and k is 2. So 1 minus 2, it will be minus 1. So minus 1 is not present in our map. Let's have our map also. What is present in our map? So currently 0, comma 1 is there. 0 is the key and 1 is the value. Okay, so initially count will be 0. Yeah, count is 0. So I checked in my map that sum minus k, that is 1 minus 2 is not there, so it will be 0 only. And I will add that sum to our map. So sum is 1. So in my map, 1 comma 1 will be there. 1 sum 1 and with count 1. And then coming to next element, it is again 1. So I will add to my sum. My sum will become 2. And I will do sum minus k. Sum is 2 and k is also 2. So in my map, 0 is there with value 1. So I will add it to my count. So my count will become 1. And again, I will add the sum into my map. So sum is 2 with count 1. So sum is 2 with count 1. Now we will move to the next element, which is again 1. So again, we will add this to my sum. So my sum will become 3. And again, I will do 3 minus k, which is 3 minus 2. So 3 minus 2 is 1. So I will check whether it is present in my map. Yeah, it's there with count 1. So I will add this to my map. So it will become 2. And after that, I will add this sum to my map. So which is 3. So it will add 3 with 1. So this is the logic. So let's see the code. Yeah. So I have taken the unordered map and initialized 0 with 1 for considering the sum value equal to k, and have taken the sum equals to 0 and count equal to 0. And after that, I'm iterating over the array and adding the element to my sum and checking not if it is if sum minus k will be present in my map, then it will, whatever value will be there, it will add into the count. Other else it will add 0. And after that, I am adding that sum to my map, and I'm returning this count, which is my result. So let's run my code. Yeah, so it's passed all the given test cases. Let's submit it. Yeah, it passed all the given test cases. So time complexity, let's discuss the time complexity of it. So time complexity for this code will be O of n, as we are running a single loop for iterating over the nums of size n. And space complexity will be O of, again, O of n for tracking the prefix sum. So time and space complexity both will be O of n. So that's it. Thank you for watching. Do like, share, and subscribe.